and gentlemen. Today we're talking about section 4.2, which is applying congruence in triangles. And let's start by talking about what it means to be congruent. So what you all may remember from middle school is that to be congruent, two shapes have to be the same size and the same shape. For example, all three of these figures are the same size, the same shape. They're just in different positions. Some are rotated, some are flipped, but they're still the same size and shape. Not being congruent, they might be the same shape with different sizes, or the same size with different shape. They have to be both. For the formal geometry definition of congruent figures, it means all the corresponding parts are equal, or are congruent. So you may ask yourself, Mr. Fillmore, what are congruent parts? I'm glad you thought that question. Here's the answer. It's a pair of sides or a pair of angles that have the same relative position in two congruent figures. So for example, with these two figures, if I were to choose this small angle down here, that's congruent to the small angle over here when it's rotated, or over here when it's rotated. That's why it's relative position, because it's not always the same spot. You have to pay attention if the figure's rotated or not. So let's do an example with that, shall we? Let's list all the corresponding sides, corresponding angles, and we're going to write what's called a congruence statement. Starting with corresponding sides. Can anyone identify what a pair of corresponding sides might be for these two pairs of triangles? Go ahead, sir. Nope, we're looking at both pairs of triangles. No, we're looking at sides. Elise?
AC and FD.
AC and FD, right. So this bottom side with two tick marks is corresponding to this bottom side with two tick marks. So AC and FD. That's one pair of sides. So AC and FD. Another pair of sides, Tiana.
EC and ED.
Say it one more time. BC and ED.
Oh yeah, BC.
Good. These two are corresponding. Correct. In their corresponding position. So BC and ED. And then there's one other pair here as well. Philip? AB and FB, except we're going to say AB, and you say FE. That's fine. Yeah, so AB and FE, going from bottom to top, bottom to top. Those are all of our pairs of corresponding sides. For corresponding angles, we're going to do the same thing. What angles are in the same position? Well, one pair is that we have angle A and angle F are in the same position, so those are corresponding angles, so angle A and angle F. Another pair of corresponding angles would be B and E, both in the same position, so angle B and angle E. And lastly, the last two, angle C and angle D, corresponding positions. Now, to write a congruence statement, it's a statement that basically states that two different figures are congruent. In this case, we're talking about triangles. With triangles, we have to use the symbol for triangle, because we're going to use three letters to name the triangle. But if you use three letters without your triangle symbol, I don't know if you're talking about a plane, an angle, or triangle, right? So I'm going to call this triangle ABC. And then write my congruent symbol and write my other triangle. But when I write my other triangle, the letters have to remain in the same order. So if A came first, the corresponding angle F should come first. If B comes first, then E should come first. And if C is last, then D should be last. So that's my congruent statement. If I were to change the order of my first triangle, instead of ABC, let's say I call it BAC, I would have to change the order of my second triangle as well. So B corresponds with E, A corresponds with F, and then D would stay last. So those are two examples of a congruent statement here. But let's look at an example where these are rotated. If you would like to attempt this on your own, pause it and then check your answer when I go through the solution, or you can just go through the solution now. All right, so for an example where we're doing, like I said, when they're rotated, let's start with the congruence statement. So this first triangle, I'm going to just go alphabetically and call it JKL. So triangle JKL. If I were to rotate this, what would be in the same place as J? It's not going to be R because these are rotated. If I were to rotate this second triangle, T, would end up being in the same place as J. It's on one end of the short side, but it's not the one with the single tick mark, it's the one with 3. So those two are corresponding here. For K, it's going to be S. For L, if I were to rotate this, it would be up here at R. So there's my congruence statement. Now we can use our congruence statement as well as the picture to identify corresponding parts. So with sides, let's say I'm talking about JK. It's going to be the same as TS. Shortcut, JK is the first two letters, TS is the first two letters. So you can look at your picture or just look here. Another pair, if I look at my second two letters, and I'll confirm it with the picture, KL and SR. Over here, they are in the same position, KL and SR. If I were to rotate them, they're in the exact same corresponding position. Now let's do green. And lastly, I can pick my first and last, JL, first and last, TR. JL and TR. Both are corresponding to the two long sides. So again, you can use the picture or use your congruence statement. I'm just going to use my congruence statement for my angles because it's much quicker. Angle J is first, angle T is first. K is second, S is second. L is last, R is last. Those are all my corresponding angles. Next, let's actually apply this and solve for some missing information. Here, we're given the fact that these two quadrilaterals are congruent. That means all of our sides match up and all of our angles match up and are congruent. So for A, we're going to use that fact to solve for the measure of angle x. Well, I have x's in two expressions, 6y plus x and 2y minus 4. I'm going to use the 2y minus 4 because I don't know what y is, so this won't help me very much. So this is side QR, it's 2x minus 4. Well, I need some values to be able to help me solve for x. I have a lot of values over here. So let's see what side corresponds to QR. QR is my last two letters, so FG corresponds to QR, which is down here. And if I rotated these two figures, so if I rotated this, it would look like this figure, you would see that both of these would be on the bottom. So they're going to be equal. So 2x minus 4 is going to equal 12 because these are corresponding parts. And they're congruent because the figures are congruent. If I solve for x, I'll add 4 to both sides. So 2x equals 16. Divide both sides by 2, and x is 8. So x equals 8. Finished with that part. I'll do the same thing to solve for y. I only have one expression here that has y in it, and that's 6y plus x. I know what x is. It's 8. So this is really 6y plus 8. This is located up at angle Q. So what corresponds to Q? The third letter in this figure? F. And if I were to rotate, you would see that both of them would be in the bottom right-hand corner. So my 6y plus 8 is going to equal that 68. Because again, they're corresponding parts in congruent figures. So those parts are congruent, those two angles are. If I solve for y, I'll subtract 8 from both sides, so 6y equals 60. And divide both sides by 6 to get rid of this guy, so y equals 10. So those are my two answers for this example. Feel free to pause and rewind as needed. Just a simple example to supplement if you were absent or if you want to look at these again to review for something. Let's look at a theorem and an example with that theorem. So the third angles theorem says this. If you have two triangles, and let me just read it. If two angles of one triangle are congruent, two angles of another triangle, then the third angles are also congruent. So if these are congruent and these are congruent, we can logically conclude that the last pair is going to be congruent too. That's the third angles theorem. To make that kind of concrete, let's say this was 90 degrees. And let's say that, we're going to pause that because the music's on. Sorry about that. So again, that first angle is 90. Let's say the second one is 40. Well, if this is 90, so is this angle over here because they're congruent. I should probably put my degree symbol here. Let me make this a little better. And since this is 40, this angle should also measure 40. So if these three interior angles add to 180, then this last angle has to be 50, because 90 plus 40 plus 50 is 180. 90 plus 40 plus 50 is 180. So if these two angles are the same, the last pair of angles has no choice but to be the same. It should be 50. Quick little example, we've discussed this in class and we'll continue to discuss it. As an example though, let's look at a problem where a couple triangles are overlapping, because that can be a difficult distinction to make. Here we're asked to find the measure of angle BDC. This can be very difficult because these two triangles are overlapping. There's two large ones to make these three small ones. So really I have this large triangle here. So let's draw them separately. Since we're looking for an angle of the large triangle, let's draw our two large triangles separately. So there's one. And let's label that correctly. This was B, this was D, and this was C, and I had two tick marks here, and I had one tick mark up here. Now let's do the other one, and let's draw this separately. Again, because we're looking for a large angle and a large triangle, so we can pull out the two large triangles here. So this was A, C, and D. I had one tick mark at the top, and it was 45 degrees. I had two tick marks at the bottom, and it was 30. So this is 45, so is this one, and let me do that a little bit neater. This is 30, so is this one. And I'm looking for the measure of angle BDC, which is this missing angle here. Well, I know that all three of these should add to give us 180. So 45 plus 30 plus this missing angle should equal 180. Well, if I add these together, I get 75. So if I take 180 and subtract my 75, I end up with 105 left over. So this is 105 degrees. So the measure of angle BDC is 105 degrees. So it's important, if you have a problem that's difficult to solve, try separating the overlapping triangles and then solving. It won't work every time, but sometimes it can make a problem much easier. If you are in my 5th, 6th, 8th, or 9th period, this is the end of your notes. If you're in my 1st or 2nd honors class, take a look at the proof in the next slide. Here, we're given a lot of information, which is great because we have a lot of information we can work with. And we're asked to prove that these two small triangles are congruent. Well, to know they're congruent, we have to know that all the corresponding sides are congruent and all the corresponding angles are. So this person started with the sides. So they split up the given information and just used the sides first. So we know those two pairs of sides are congruent because it's given to us. And it's also shown in the picture. Well, you should notice about the third pair of sides, it's the same side, AC. It's shared in both triangles. It's a common side. So we're going to say that AC in the first triangle is congruent to AC in the second triangle, that it's a shared side. So anytime you see this, if something is equal to itself, it's usually because it's a shared side. And the property that says something is congruent to itself is our reflexive property of congruence. We use that whenever we have a shared side or a shared angle. The AC in triangle, the first triangle is congruent to AC in the second triangle because they're shared. So we use the given information with the first two pair of sides, and we use the reflexive property with our third pair of sides, and so all of our corresponding sides are congruent. Now let's focus on the angles. The second part of our given information is that two pairs of angles are congruent. And like I just said, that was given to us. And it's also shown in our picture that these angles are congruent. Well, if we know that two pairs of corresponding angles are congruent, we can deduce or conclude that the third pair will be congruent as well. And that's the theorem we just went over, the third angles theorem. That if two pairs of corresponding angles are congruent, so is the third pair. That's hence the name third angles theorem. So then we proved all of our angles here, all of our corresponding angle pairs, are congruent. Well now, since we know that all of our sides are congruent, and all of our angles are congruent, we can conclude that our triangles are congruent. And that's simply using our definition of congruent figures, which says corresponding parts are congruent in any two congruent figures. So we always use the definition of congruent figures to conclude that they are congruent. Now I must say this, we'll look at some shortcuts starting in section 3 that we can use to replace this, and it makes our proofs a little bit easier to do. This concludes section 4.2. I hope this video is helpful and that it helps you review or study or what have you.